Aircraft cannot go into space due to some laws of physics. First of all, we need to know some laws of physics. The density, quantity and pressure of the air decreases as we move from sea level to higher altitudes. So what effects does the decrease in the density, quantity and pressure of the air have on us? The most important effect is on aircraft engines. The inner part of the engines of today's passenger aircraft, which we call the core, consists of low-pressure compressor plus high-pressure compressor plus combustion chamber plus high-pressure turbine plus low-pressure turbine. If the aircraft engine cannot get enough air, stall occurs at the compressor stage. At the same time, three things are required for combustion to take place in the combustion chamber. These are fuel, ignition and air. We have fuel and ignition, but considering that the amount of air at high altitudes will drop very low and even there is no air in space, the aircraft engine will stall again after a certain altitude, since there will be no combustion without air. The second reason why aeroplanes cannot exceed an altitude of about 12 kilometers, about 40,000 feet, is related to aerodynamics. Flying at high altitudes has an advantage and a disadvantage. The advantage is that at high altitudes, the amount of air is less, so the drag force to which the aircraft is exposed is naturally less. This is why all passenger aircraft, even if they are flying a short distance, try to reach the highest altitude they can as soon as possible, rather than flying at low altitude. Do not call it drag, the biggest advantage of this is fuel saving. The disadvantage of flying at high altitudes is that as the amount and density of air decreases, the carrying force generated in the wings will also decrease, and since there will not be enough carrying force at very high altitudes, the aircraft itself will stall as well as the engine of the aircraft. Today's passenger aircraft wing design and engines are designed to be suitable for flying at a maximum altitude of 12 kilometers. The wing design and engines of the Concorde aircraft were designed to fly above an altitude of 40,000 feet, but the Concorde could fly at altitudes within the atmosphere at most. Another thing we need to know is that humans can live in conditions with the amount and density of air at a maximum of 9 to 10,000 feet. So if the density and amount of air decreases as the altitude increases, how can passengers survive in an aircraft flying at 39 to 40,000 feet? What enables passengers to survive at those high altitudes is the pressurization of air inside the aircraft. In other words, thanks to the pressurization system of the aircraft, passengers can travel comfortably at such high altitudes. The pressurization system of the aircraft is a part of the air condition system of the aircraft. The air condition system, in turn, obtains this air from the compressor stages of the aircraft engines. If all the engines of the aircraft go into stall due to lack of air, naturally, the aircraft will not be pressurized because we will not be able to supply air to the pressurization system, which will cause all passengers and crew on board to be asphyxiated and life-threatening. Even if the engines somehow work at these high altitudes, flying at altitudes above 40,000 feet will also reduce the airframe life endurance of the aircraft, as the ambient air pressure will be very low and the aircraft will inflate much more than normal. The uppermost layer of the atmosphere is located at an altitude of approximately 100 kilometers above the Earth's surface. Current aircraft are not designed to reach this altitude anyway. Even if you build an aircraft that can reach this altitude, you will have to manufacture the fuselage in a way to protect the passengers and crew from the effects of radiation.